Okay, dear students, today I will be explaining you Wheatstone Bridge. So let us start with Wheatstone Bridge. Now we will be using Kirchhoff's voltage law in explaining the principle of Wheatstone Bridge. First of all, let me draw the bridge. Now, the Wheatstone Bridge consists of 4 resistors. The Wheatstone Bridge consists of 4 resistors. Let us name them. This resistance is P, this is Q, this is R and S. So it's like this P, Q, R, S. Now, in between, let us name this bridge. It is A, B, C and D. Now in between B and D, we connect an instrument called galvanometer. So we connect an instrument. This instrument is known as a galvanometer G. Now before explaining Wheatstone Bridge, let me tell you what is a galvanometer. A galvanometer is an instrument to detect sensitive current, just like your emitter. Then what would be the difference between emitter and galvanometer? An emitter only gives you magnitude of large current, whereas galvanometer not only gives you the magnitude of current, small current, but also it gives you the direction of the current. So galvanometer is an instrument which gives you the measurement of small current and also the direction of the current. An emitter is nothing but a galvanometer, which we will be explaining you in the subsequent classes. Now, here is the galvanometer which is used to detect current, is placed between B and D. Now, between A and C, we connect a cell. This cell is of EMF E. So P, Q, R, S are the 4 resistors in the 4 arms of the Wheatstone Bridge, and between B and D we connect a galvanometer, and between A and C we connect a cell of EMF E. This whole bridge is known as a Wheatstone Bridge. Now let us give you the direction of current in this bridge. From here we take a conventional current I. This current I comes to the junction A and splits 2 ways. Now here let us take the current here this way as I1. So the rest of the current will be passing across AB or the resistance R. So how much will be the current across AB? It will be I minus I1. So I is coming up to the junction A and getting split into 2 halves, I1 and I minus I1. This I1 goes up to the point B. Here again it splits into 2 parts. So let us assume that the current to the galvanometer is Ig. So Ig represents the current to the galvanometer. So the rest of the current goes across BC. So what is the amount of current that is going across BC? It is I1 minus Ig. So this I minus Ig goes to the point C. From here, from the point D, we see that Ig and I minus I1 are joining together, and amount of current Ig plus I minus I1 is moving towards the point C. Now this amount of current is moving from D to C, and an amount of current I1 minus Ig is moving from B to C. So what is the current flowing through C, to the cell? If you see properly, it is I 1 minus Ig plus Ig plus I minus I1. So we add them. These two currents are being added at the point C. Here you see Ig cancels and I1 and I1 gets cancelled. This Ig and Ig, I1 get cancels, and an amount of current I enters the cell. So, as I have explained you in the earlier classes, that the amount of current coming out from a cell must be equal to the amount of current coming into the cell. In other words, in each of the cells, conservation of charge must be maintained. Now, we find out the loops here. You see in this Wheatstone bridge, if you connect point B and B, so one thing more I should tell you, that here we have taken Ig, the current to the galvanometer, from B to D. The current to the galvanometer is from B to D. In other words, point B is at high potential with respect to point D. Point B is at high potential with respect to the point D. That is the assumptions that we have made. All the currents here, all the directions are nothing but arbitrary. Here, you can give the current is flowing from D to B, and accordingly you can make the circuit and you can distribute the current. Now, you see, let us take two loops. The loop number one is A, B, D, A. This loop, A, B, D, A. Let us take it in this direction. If we take it in this direction, A, B, D, A, then we find that the loop equations will be I1P plus Ig into G minus I minus I1 into R is equal to 0. Now let me explain you this equation. Here you see that the current is moving from A to B, and so is the direction. First we have moved from A to B, the current is also moving from A to B. So here I1P, P is the resistance here, is positive. Next we move from B to D, the current is also moving from B to D. So IgG is taken as positive. This part is taken as positive. Here G is nothing but a resistance of the galvanometer. Next, when we move from D to A, the next is from D to A. From D to A, the current is moving from A to D. So I minus I1 into R is taken as negative. Now if you see properly, in this loop A, B, D, A, there is no cell. If there is no cell, then it is equal to 0. Because remember Kirchhoff's voltage law, summation of IR is equal to summation of E. So here is no cell, so we write it as 0. This side is summation of IR and this side is for the summation of E. So no cell, so we write 0. Again, let us take another loop. Loop number 2 is, let us name it first, loop is B, C, D and B. This loop, B, C, D, B. Same direction we are taking in both the loops, B, C, D, B clockwise, B, C, D, B. So if you see, first we move from B to C. If we move from B to C, I1 minus Ig into Q is positive, then minus Ig plus I minus I1 into the whole thing is multiplied by S. So Ig, I minus I1 is S, and this is negative because we are moving from C to D, the current is moving from D to C. And lastly, we are moving from D to B, the current is moving from B to D. So minus Ig into G is equal to 0. So we find two equations. This is equation number 1 and this is equation number 2. Now, you see, if we take that point B and point D are at same potential, if point B and point D are at same potential, then no current will flow through the galvanometer. Let me repeat. If point B and point D are at same potential, no current will flow through the galvanometer. In that case, Ig will be equal to 0. So let us write it as if, because we shall prove something more, the Ig is equal to 0. We have considered B and D to be same potential. If we put Ig equal to 0 in both the equations, what we get from here? We get equation I1P is equal to how much? Is equal to I minus I1 into R. That is equation number 3. And from here, you see, if Ig is equal to 0, we get I1Q is equal to, this part is 0, this is 0 again, and this part is also 0. So let us shift to this side. This becomes I1 minus I1 into S. So this is equation number 4. Now if we divide equation 3 and 4, we get it as P by Q is equal to R by S. P by Q is equal to R by S. So let us write it. Let us write it on the top. Let us write it on the top. It is, we get, dividing equation 3 and 4, we get P by Q is equal to R by S. Now this is a condition for a balanced Wheatstone bridge. Now what is a balanced Wheatstone bridge? The balanced Wheatstone bridge is a bridge when no current flows through the galvanometer. In other words, the galvanometer will show no deflection. The galvanometer is an instrument like this. It's marked 0 here and divisions 1, 2, 3, 4 like this. And you have a pointer here. If this pointer moves towards the right, the current is moving from B to D. It is moving forward to the left, the current is moving from D to B. And if no current flows, the galvanometer will be pointing towards 0. The galvanometer pointing towards 0 shows that no current or the point B and D are at same potential. So when this is the case, P by Q is equal to R by S. This is, what is the condition for this? That Ig should be 0. No current will flow through the galvanometer. This is called a balanced Wheatstone bridge or Wheatstone bridge. Wheatstone bridge principle. Wheatstone bridge principle. Now, you see, why have we studied all this? What is the importance of Wheatstone bridge? The importance of Wheatstone bridge is that this bridge can give the measure of an unknown resistance. Now you see, if we have three resistance P, Q, R as known, and the third one, say X, is an unknown resistance. So we have three known and one unknown resistance. If we adjust the resistance of P, Q and R in such a way that the bridge is balanced, in other words, no current flows to the galvanometer, then we have P by Q is equal to R by X. In other words, X is equal to Q into R divided by P. So, if you know Q, R and P, this unknown resistance can be found out. This method is used to find out the unknown resistance of long of wires by means of an instrument called post office box. Unknown resistance, small unknown resistance can be found by another bridge, modified bridge of Wheatstone bridge known as meter bridge. That I will be explaining you in the next class. In the next class, we will see how to find out the unknown resistance using Wheatstone bridge principle. Thank you for now.